Starting up the stream. Should be going soon. Alright. Hi everyone, I'm TigerHawk23, and today we're going to write more in the Deque. This double-ended queue that we've been working on. It says it's 700 lines, and about half of that so far is docstrings. So, let's write a docstring. A Deque string, because it's for a Deque. Get it? Anyway, contains return whether item is in the Deque. Parameters item, which is any object, and that's the item to search for. And returns result, I guess, which is bool, whether item in Deque. Great. Now mul. Okay, this does a specific thing, and this is expecting an integer. An int, and so we can have our Deque times a number, and it will give us a new Deque repeated so many times. Returns a new Deque consisting of the current Deque's references repeated repeated other times. Okay. Parameters other, which has to be an int, and that's gonna be number of times to repeat stack, I guess, something like that. Parameters, and it returns a new Deque of type Deque, and that is the resulting Deque. Great. And this one, imul, is the in place when you do times equal. The augmented assignment is what that's called, and that is expands the current Deque to contain other repeats of its references. Okay. Parameters other, which is number of times to repeat this Deque, and it returns, it has to return self. This returns this Deque, this one. Now we're going to add something, and what we're going to add is something that was not mentioned in the collections.deque documentation as something that it supports, but it does. It just doesn't mention it. And that thing is rmul. And that's going to be return self times other. Great. Copy the docstring. Repeat it other times. for reflected operands. Okay, so this is when you have, instead of d times 3, when you have 3 times d, because the integer type doesn't have defined behavior for when you multiply one of those integers by a Deque, because that's our custom class. So it's going to say maybe the custom class has something for when we do that. And all we do here is self times other, basically send it to mul. We might have the behavior we want for this is commutative, meaning it can be reversed. 3 times d is the same thing as d times 3. We want the same result. So we can just do this, but if it had to be something specifically different, then we would have, we would need to call that method, and we'd need something a little more specific to say they should be reversed. And we would do that for, say, subtraction, or division, or anything where the order matters, like matrix multiplication, for example. And for this, I tried importing this, and it actually gives useful method stubs. What are these method stubs? These method stubs are, hang on, okay, so is it this? Great. So this is our, I imported Deque in this folder, and now we're in the Deque, and we get help on this. And so there's nothing at the top. We're going to add something for that. But blah 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 blah. This is the thing we have. GT greater than, which is something which is defined over here. Notice we don't have anything, and yet it already says return self more than value. And that's what it does. I mean, we could mention that it's lexicographic, but I think that's already evident enough. That's kind of the standard way to do things. Equal, greater than, or equal, greater than. So it already has those things. Return self equal to value. Return self greater or equal value. Great. And it is those rich comparison functions that we have at the end here. Less than, less equal, equal, not equal, greater than, greater equal. Awesome. So we're done with that part. Now for node, let's actually do we need an init of some kind? What is our init here? Create new Deque, etc. Okay, I should say something about what this init does. Here's what I'm getting. For node, we have repro returns repro of self, and here return string of self. That's what it does. That's good. We're gonna stick with those. But the init is gonna be return a new node, create a new node with an optional given element. Parameters, element is any kind of object. The element this node should contain, and then doesn't really have a return I think that's the job of new or something. This is just the initializer. So we've created the object already, and then init is what gets called when we actually instantiate one. This is the little process it goes through to start out. So this is good. Returns. Should it say what it returns? If anything, technically this method does not have any return. None creates the object, initializes. It really does initialize. Okay, because it's already created, but we're just setting some basic stuff. Okay, and now I want this. I'm going to put this here. So let's see. Does this show? Oh, in chat, JC Abby says, "Hey man, hey." Is this the right window? No, it is not. I want the other PowerShell. Thank you. Okay, so this is for collections.deque on class deque and module collections, and it has this basically to start out with at the top. So that's for the object itself, not for its methods. So we're going to basically do that. Let's do node first. Okay. Node and the element is optional, and I'm just gonna not specify the other args because this is only here so that if you get something created by the repro, you can send it to eval and it won't explode necessarily. So it can just handle more arguments, doesn't do anything with them. And it's a node object. And this one is a singleton container for objects in a deque. Fantastic. Gonna do something similar for this. This is Deque, has an iterable optional, maxlen also optional. It's a Deque is the class name. A list-like sequence, optimized for data accesses near its endpoints. Now here we will say a pure Python implementation of collections.deque with added features like the remove and replace stuff have more things, like you can remove or replace anything or a certain number or from the other end, that sort of thing. And especially next time we're gonna have even more, because I decided entirely unilaterally that I want other stuff, matrix multiplication and element-wise operations. So I might actually fork this repo First I'll do matrix stuff, and then dodging bullets, right? No, I mean like a sequence, or a 2D sequence. Yeah, matrix multiplication. It's a thing. So first I'm gonna do that, and then after I would like the regular arithmetic operators like plus, minus, that sort of thing, to be element-wise. So if I have a deck of 1, 2, 3, and another deck of 4, 5, 6, and I do the first one plus the second one, I would get a result of, instead of 1, 2, 3, 4, 5, 6, I would get a result of 5, 7, 9, because it's adding each one together. So I've decided that I want that because I feel like it. So probably when I do that, I will fork this into a different branch, because it's not going to behave just like the standard collections.deck. You would add 2 of these decks and get something different than if you did it in the standard one. So I'll probably have a different method that concatenates, that I'll call concatenate or concat or plus, or I can just have a whole bunch of aliases is what I'm considering. And then we'll just do like something that, you know, adds the decks together, concatenates them, and then like returns itself the new one or something. So instead of result equals A plus B plus C, it would be result equals or A equals, or not any equals. You just do A dot plus B dot plus C, something like that. Anyway, that's going to be later. For now, all we did was add RMUL and let me do a little something. Just gonna test. Name's main, and yes, sometimes this is important rather than just putting a bunch of extra code at the bottom. I ran into this a few days ago with multiprocessing, which totally breaks if you put test code at the bottom, not inside such a block. And Sunny Torres in chat says, sweet. We're doing the coding. D equals, actually we can just do print deck of 1, 2, 3 times 2, and then 2 times that. Great. So that's mul and rmul. And let's test this out. Do I have a window for this already somewhere? Not particularly. Let's pop one of those. Isn't it called that? Alright. Oh, I forgot this up there. Sonny Torres in chat asks, are you contributing to Python's built-in functions or source code? No. We are building a pure Python version of a deck for fun. If you actually need a deck in your project, whatever you're doing, use the standard one because it's written in C and it's much, much faster, except for the reverse, because that actually moves a whole bunch of things around, while the one in this version just tells us to look at the deck backwards. So it's O of 1. which is so neat and caused so many headaches. But here we go with this. Good. We have our deck of 1, 2, 3 times 2 and 2 times 1, 2, 3, and both of them are 1, 2, 3, 1, 2, 3. Fantastic. That's all that I wanted to test. Now I'm going to take this out. We've got our docstrings. We've got armol. 20 minutes. Short stream is okay. We were just adding a couple things. So I think now it should... anything you can do with collections.deque, you can do with this, and it will behave the same, only much, much slower most of the time for almost anything you do. Sorry. But we're writing it in Python and not in C. And so next time, I would say, is going to be matrix multiplication, which is going to look something like this. Yeah, I already kind of wrote it, but just for a subclass of list, so I could define some new methods for multiplication and reverse multiplication. Matrix multiplication is not commutative. A times B is not the same thing as B times A, necessarily. So yeah. Oh, yeah. Matrix multiplication is a different one. This is the element-wise, and element-wise the other way. This is matrix multiplication, this whole thing over here, with multiprocessing. Ooh, fun. Anyway, then I wrote a bunch of matmul, meaning my matrix at equal. So an augmented assignment instead of my matrix equals my matrix multiplied by another one. And this is the element-wise multiplication, and here's the at, because it's matrix. Get it? Anyway, and so here's a few different styles that I wrote, and we will use one of them for the deck, probably this one, because I think it's more efficient, as far as I know. And this stuff will be next time. And then after that, I think I will fork the repository into a new branch, and that branch will have, instead of plus being concatenation, we're going to add an ordinary method for concatenation, and make all the operators element-wise. So that's the plan. That's the plan. Where am I? Alright. That's it for today. Thanks for watching. Make sure to like, comment, subscribe. You can watch archived versions of previous streams, and watch brand new live streams all on this channel. And I'll see you again soonish. JC Abby says, have you ever done blockchain stuff? No, I have not. I've heard of that word for like cryptocurrency stuff, but as far as doing anything, no, I have not. So that's the plan for next time and after, and I will see you then. Thanks for watching, and have a good one.